Alright, so in this section, we're going to talk about shifted conics. So, really, you will shift the conics similarly to how we have shifted any of the other graphs that we have talked about. So, if you look specifically at an ellipse here, you'll see that we always started before with an ellipse started at the origin. But if you want to shift the ellipse, say over here to a a location where the center is at HK instead of at 0, 0, then this will be the new equation of the ellipse. So x minus h squared over a squared plus y minus k squared over b squared equals 1. Alright, and remember, for this particular setup here, the A has to be bigger than the B. So the A will actually tell us whether the major axis is horizontal or whether the major axis is vertical. So let's look at an example here. Alright, so let's remember that the form is x minus h squared, and the a is always going to be over the under the one where a is, well, the larger number. So this is actually over 1, and then this is over 4. So that means a squared is actually the 4. So x minus h squared over b squared plus y minus k squared over a squared is equal to 1. Alright, so now the chat window got in my way here, so I'm going to actually close the participant window because I know that both of you are here, so that I can actually see what is what is going on here. So let me write down what we are going to be asked to find here. Alright, so we need to find the center, and the center is going to be HK, and then we need to find the vertices, and since this is shifted from the origin and it is a, well, because the number under the y term is larger than under the x term, we know that the major axis is vertical. So the vertices are actually going to be h and then k plus or minus a. All right, and then the foci are going to be, all right, so this is going to be h and then k plus or minus c, and then we have the, well, all right, lengths of the major axis. So the lengths of the major axis are going, well, that's just going to be 2a again. So lengths of major axis is just 2a. All right, so once I figure all of this out, then I can just go ahead and sketch it from there. All right, so I see for this particular example, the h is 0, the b squared is 1, so b is 1, the k is negative 2, the a squared is 4, which means that the square root of 4 is 2, so a is 2. So I have everything I need. So now the center is at HK, so that's 0, negative 2. And the vertices are at H and then K plus or minus A. So 0 and then K was negative 2. So negative 2 plus or minus 2. So then we have 0, and negative 2 plus 2 is 0, and negative 2 minus 2 is negative 4, so 0, negative 4. And then we still need to find the c, but remember the c squared was a squared minus b squared, so a squared was 4 and b squared was 1, so we have c squared is equal to 3, and then if I take the square root of 3, then that will be, let me do an estimate for you here. So the square root of 3 is about 1.7. Alright, so then we know that the foci are at hk plus or minus c, so 0, negative 2 plus or minus the square root of 3. Alright, and I'm not going to actually figure out the decimal approximation of the foci because I'm not actually planning to graph them unless you really would like to see that, but it's not really usually necessary unless you're drawing the graph using the measurements, but we're not doing that. And then the lengths of the major axis, that's 2a, so a was 2, so 2 times 2 is 4. Alright, so now let's draw a sketch of this. So here we go. And we know that the center is at 0, negative 2. So here is 0, so center 0, negative 2. So 0, negative 2. And then the vertices are at 0, 0. So 0, 0, and 0, negative 4. And then I really need to figure out what these so-called co-vertices are, or how far I need to go left and right from the center. And so I know that since B was 1, I need to go left and right 1 from the center of the ellipse, and this is what the ellipse will look like. Alright, so there's the vertex at where was it? That was 0, 0, and there's a vertex at 0, negative 4, and that's it. There is a sketch of the ellipse. So, really, in all honesty, all you really had to do was draw the center, then go left and right 1 from the center, and up and down 2 from the center, and then you could have drawn the ellipse. All of this was just extra stuff so that you could do this sort of without having um, to actually look at the equation itself. Alright, just plot the center, the vertices of foci, and then know that you have to go and make sure that you have the major axis be a length of 4. Alright, let's try again. Find the center, foci, vertices, and eccentricity of the ellipse and sketch its graph. Alright, so let me... Uh-oh. When I told you earlier I was having some problem with the windows, I wasn't, for some reason I really wasn't kidding, and I don't know what it is that's causing the issue. I don't know what's causing the issue this morning. If I knew I knew I would tell you. All right, so here we go. So I think that I found it again. All right. So find the center, foci, vertices, eccentricity of the ellipse, and sketch its graph. Okay. So you see that this one is not in the sort of standard form for the ellipse. It's in the general form. So one thing that I will point out is later on, and this will actually be in here, all right, on page 337, this will tell you how to see if the conic is a parabola, ellipse, or hyperbola. So if I look here and I I see it's in a x squared plus c y squared plus d x plus e y plus f equals 0 form, then, all right, so a is equal to 4, c is equal to 1, and d is equal to -8, and the e is equal to 4, and the f is equal to -8, then if a and c have the opposite sign, which actually, yeah, if a and c have the opposite sign, then this is a hyperbola, and if they have the same sign, it's an ellipse, and if one of them is 0, it's a parabola. So when I say the same sign, I mean a and c are both positive or both negative. So these are both positive, so they have the same sign. So same sign meaning that they're both positive in this case, so that means that this has to be an ellipse. All right, so there's no doubt in my mind that this is definitely an ellipse here. All right, so now what do you do here? Well, all right, I need it to be in the form where I can figure out what the center is quickly. So I am going to use completing the square. So I'm going to rewrite this so that the x terms are together. So 4x squared minus 8x, and then let me get another color here, and the y terms are together, so y squared plus 4y, and then I'm going to actually add the 8 to the other side so that it's equal to 8 here. So one thing that I am going to think about is how am I going to complete the square for 4x squared minus 8x? Well, all right, I'll go one at a time. So this one will actually be easier because there's not a coefficient other than 1 in front of the y squared. So I'm going to start there just to make sure that you're clear on what's going on. So remember, if you remember anything about completing the square, you would add 1/2 of b squared to each side of the equation. All right, so plus 1/2 of b squared to each side of the equation. All right, but the b squared, all right, 1/2 of b squared. All right, so I do need parentheses there just to make sure that we're clear on that. All right, so here the b was 4, so that will be y squared plus 4y plus 1/2 of the 4 squared. Add it to each side. And then I see that 1/2 of 4 is 2, so that will be 2 squared, add it to each side. And then what you have here, so 2 squared is actually 4, so I have y squared plus 4y plus 4. And then I can factor this into y plus 2 times y plus 2, or y plus 2 squared. All right, I'll figure out what this is in a minute. I want to work on figuring out this part over here now. All right, so 4x squared minus 8x. So just remember that this is easier if the coefficient was a 1. So what I'm actually going to do is I'm going to factor out the 4. So 4 times x squared minus 2x. And then what I will do is I'm going to add a half of the middle number squared. So a half of the -8 squared, add it to each side. But remember that because I factored out the 4, all right, I actually have to add 4 times a half of the -8 squared to each side. All right, let me focus that because that 8 on the right side there was a little bit blurry for some reason. All right, there we go. So now a half of the negative 8 is 4, so negative 4 actually squared. So we have 4 times x squared minus 2x plus a negative 4 squared plus all of that, and then we have 4 times x squared minus 2x plus 16, and then we have 4 times. All right, so what are you going to have actually not negative 8. I I said negative 8, but I knew it. I said negative 8. I told you there were things flowing around in here, and this I knew that was actually I said it as soon as I knew it that was too high of a number. And I knew it seemed like too high of a number, but yeah, it's negative 2. There we go. I have no idea. I have no idea why I was looking up here, but negative 2. So negative 2 squared, half of negative 2 squared is negative 1 squared, and negative 1 squared of 1. So that's actually negative 2. So plus 4 times negative 1 squared, so plus 4 times 1, so plus 4 here. All right, so I'm just bringing them all down, but you see my methodology here, hopefully. I just was looking up here for some reason. I told you there's things blowing around here. So now what do we have here? We have, if I factor this, x minus 1 times x minus 1, and so then this becomes, 4 times x minus 1 squared, and here, 8 plus 4 is actually 16. All right, so what do we have here? We have 4 times x minus 1 squared plus y plus 2 squared is equal to 16. So that is the equation of the ellipse. All right, now that it's in a form where I can find out what the h and k is here, then all right, so here we go. So we have 4 times x minus 1 squared plus y plus 2 squared is equal to 16. And actually, just in case you didn't notice, page 331 is a blank also. And then because I want it to be equal to 1, the equation to be equal to 1 on the right side, I'm actually going to just divide each term by 16 here. So I have x minus 1 squared over, so 4 over 16 is 1/4, so that's a 4, plus y plus 2 squared over 16, and 16 over 16 is equal to 1. All right, so if you need me to go back to that page, just let me know, but now what I am going to do here is just figure out which one should be the A and which one should be the B, but this is the larger one here. So because the larger number is under the Y, I know that this has to be A squared and this needs to be B squared. All right, and then also that this is going to be a ellipse with a major axis that is the vertical axis. All right. So the form again is of x minus h squared over b squared plus y minus k squared over a squared is equal to 1. So if I compare here, I see that the h is equal to 1, the b squared is 4, so b is 2, and y is equal to negative 2, and a squared is 16, and a is the square root of 16, so 4. All right, so now after that, all I need to do is go ahead and write down all of the information we were being asked for. So the center is at HK, and the foci are at the, where is it? Oh, yep, H and K plus or minus C. And then we have the, where is it? What else did they ask for? Oh, the vertices. The vertices are going to be at HK plus or minus A. And then we want the eccentricity. And that was E is is C over A, and then they want us to sketch the graph. So this one did not ask us for the length of the major axis, but we could figure out what that is if we wanted to, right? Length of the major axis is always just 2a, so 2a in this case, 2 times 4 is 8. All right, so now let's go ahead and figure out what this is going to be. And again, you could sketch this without even knowing all these other items by just looking at the equation, or you could use this information to find the equation no matter what type of problem this happens to be. So we know that the center is at HK, so that will be at 1 and -2. So 1 and -2 is the center. And because the A is 4, all right, and we know the major axis is vertical, we have to go 1, 2, 3, 4, 1, 2, 3, 4, up and down from the center. And since the B was 2 and this is the minor axis, then we go 2 left and right from the center. So 1, 2, and 1, 2, and then we draw the ellipse. All right. So this is actually not anything that you have not done yet, but here is one of the vertices, and here is one of the vertices, and just so that you're aware here, the foci then are HK plus or minus C, so H is 1 and K is and I actually wrote Y and not K. I have no idea why, but it is the Y value of the center, but -2 and then plus or minus C. So we need to figure out what C is. So C squared was A squared minus B squared. So A squared is 16, B squared is 4. So 16 minus 4 is 12, and C is the square root of 12. So -2 plus or minus the square root of 12. And again, I'm not going to graph that, so I'm not going to find the decimal here. And the vertices are at HK plus or minus A. So that will be 1, and then -2 plus or minus A, which is 4. So we have, well, what do we have here? Well, one of them is 1 and -2 plus 4. So that will be 1 and 2, so that was this one. And then the other one is 1 and -2 minus 4, so that will be 1 and -6, and that was this one right here. All right, and then the eccentricity is C over A, so this will be the square root of 12 over 4, and square root of 12 over 4 is going to be, whoops, okay, so let me figure out with the calculator here. That will be approximately 0.866. So if you remember what I've been saying before, then the eccentricity really just tells you how elongated the ellipse is going to be. All right, so now before we move on to the next page, I want to point out one other thing to you real quickly that I actually did not say before, because both of these happen to be an ellipse with a vertical major axis, right? So let me just show you real quickly what will happen if you have a horizontal major axis. All right, so what am I, let me find the right window here again. All right, so here we go. So if you have a vertical axis, so the major axis is vertical, then I said that the center would be the center would be at HK, but then the foci are at h and k plus or minus c, and then the vertices are at, all right, so vertices are at, oh, where was it? It was, oh, here it was, h and k plus or minus a, and then if the major axis was horizontal, which we have not actually done one of those yet, but if it were, then the center is still at hk, but the foci would be at h plus or minus ck, and then the vertices would be at h plus or minus ak. So it's all a matter of whether you're adding the c and the a to the x value or in the c and the a to the y value. That's really the only difference between these two. All right, so just try to remember that sometimes it's easier just to graph this and figure out what's going on rather than remembering the letters about what's going on. All right, so that's really the only point I was trying to make there. Sometimes, again, it's easier just to look at everything by graphing this. So here, let's find the equation of the ellipse with vertices at -1, -4, and -1, 6, and foci at -1, -3, and -1, 5. All right, so let's go ahead and we will graph this. So the vertices are at -1, -4, so -1, -4. So -1, -4, and -1, 6. So 1, 2, 3, 4, 5, 6. So -1, 6. And I know the center is halfway in the middle. So halfway in the middle would be at, all right, there is going to be the center, and it is at -1, 1. So I know that I had to go 5 up from the center and then 5 units down from the center. So there was my center at -1, 1. So I know that I have my h, and I know that I have my k now. And I know that a is going to be 5. All right, so so what do I need to do next? All right, I need to figure out what the b is, but I can do that by first looking and seeing if I can figure out what c is, but e is c over a, and then I know that c squared is a squared minus b squared. So those are the only two things I can use to figure out what the C is, right? And so I'm probably going to use this one since I don't know what the eccentricity is either. So here we go. So the foci are at -1, -3. So -1, -3, that is right here. So there's -1, -3, and here is -1. There is -1, 5. So I know that C actually then, if you look at the graph here, that C is actually the distance from the center to the foci. So that in this case would be a length of 4. See, 1, 2, 3, 4. Or 5 minus 1 is 4. All right, 5, this 5 minus 1 is 4. That's another way to figure it out as well. So since C was 4 and A was 5, then I can figure out what B is here. So 4 squared is 16, 5 squared is 25, and then I subtract the 25, so -9 is -b squared, divide by -1, so 9 is b squared, and take the square root, so b is equal to the square root of 9, which is 3. So here is the equation here then. So the major axis is vertical. So you can see that the vertices were going up and down from the center, so that means it's a vertical major axis. So that means the equation is going to be the x minus h squared plus y minus k squared, and then this will be over the b squared, and this will be over the a squared equals 1. So the a is always under the variable that defines the major axis, in this case the vertical axis. So the h was a -1, so we have x minus -1 squared over b squared, so 3 squared, and then y minus k, which is 1, so that's squared over a squared, so a was 5, so 5 squared is equal to 1. And then I go ahead and I simplify this. So if I simplify this right here, I have just x plus 1 squared over 9 plus y minus 1 squared over 25 is equal to 1. All right, what a time to be alive, right? There you go. So I really hope that you enjoyed that. I don't think it was too difficult, hopefully, but I do think that, you know, it could take a little bit of time to figure out what they're doing, especially when we're dealing with conics that are shifted like this. All right, so let's find an equation for the conic whose graph is shown. So let's look for the center right here, and it looks to be right here at 2 and -3. And then I see that this distance here is actually 2, and this distance is 3, and the a has to be the larger number, so a is 3, and B is 2, and H is 2, and K is -3. So there you go. So just from the graph, I was able to figure out all of this. So what do we have here? So we have, well, this means it has a vertical major axis again. I have no idea why I didn't put any ones with the horizontal major axis in the notes. Maybe I might need to fix that. Who knows? Or maybe not. All right. So now this means it's x minus h squared over b squared plus y minus k squared over a squared is equal to 1. So we have x minus h, which is 2 squared, over b squared, so 2 squared plus y minus -3 squared all over a squared, which is 3, so 3 squared equals 1. So our equation is going to be x minus 2 squared over 4 plus y plus 3 squared over 9 equals 1. So there you go. What a time to be alive. So there is the equation of this ellipse. All right, so again, if you have any questions, please feel free to ask, but I am going to take a moment and shift over. Well, yeah, shift over is kind of ironic here, right? Over to the next page here. So, oh, yes, so let me go ahead and find where the where where the next. Oh no, I have no idea why this is. I have no idea. I have, like I said, this is very strange that this is doing this to me. All right, so here we go. I found it. So this should be 333 here. All right. So here is information on shifted parabolas right here. So what are we going to have here? Okay, so let me say here that a couple of things that might not be as clear to you as I personally would like them to be is, what is the focus and the directrix of these parabolas once you shift them. All right, so if you shift a a parabola sort of, here, I know what the issue is. I need to just move that window over probably, because this is why it's that the camera is on top of everything, and let's see, I'll just deal with it. All right, so if you're dealing with this particular case, and actually I'll just write down the focus and then the vertex, and then so focus, the vertex, the axis of symmetry, and then the directrix for all four of these right across the top, so that you know what they are and I won't feel bad that I didn't tell you. How about that? All right. So if you have a parabola that is opening up and downward like this, then the focus is at, all right, so this will be at H, and then K plus P, and then the vertex is still at HK, and the axis of symmetry is X equals H, and the directrix, the directrix is at Y is equal to K minus P. So K minus P, all right? And then if the parabola is obeying downward like this, the focus is at, now remember the P is less than 0, so it's still H and K plus P, even though you'll be subtracting a number since P is negative, all right? And then the vertex is at HK, the axis of symmetry is still at X equals H, and then the directrix is at Y is equal to K minus P. So really, these two have the same information here. And then here, the focus for a parabola opening to the right, and remember, these two are not functions. These ones are functions. These two pass the vertical line test. These two do not, all right? So for a parabola opening to the right here, we have a focus of H plus P comma K. So notice we're just adding the P to the H now instead of to the K. All right, and then a vertex of HK, and an axis of symmetry of Y equals K, and a directrix of X is equal to H minus P. And then similarly, the same for a parabola opening to the left here. So hopefully this all makes sense of what's going on. And again, I'm just writing this out so that you have the equations, so that in the information that you need to make this as easy on you as possible. All right, that is my whole point here, is how to just make sure that you can do this, but it's also not meant to be too difficult here either. All right, so let's find the vertex and the focus and the directrix of the parabola, and then sketch its graph. So I see that this looks to be of the form y minus k squared. All right, so what will this actually be here? So now I do need to subtract this to the other side though. So y minus 6 squared will be negative 8 times x plus 7 equal, sorry, there, yeah. All right, there we go. So negative 8 times x plus 7. So I think that since this is negative, I can see that I'm in this position here. All right, so let's rewrite it so that it's in this format. So we have, all right, y minus 6 squared equal 4 times negative 2, because 4 times negative 2 is negative 8. So what you would always do is, if you're not sure what the p should be, you would take this number and divide it by 4, and that would be your p. So -8 divided by 4 is -2. And then x minus a -7 would be x plus 7. So that is of the form y minus k squared equal 4p x minus h. So the k is 6, the p is -2, and the h is -7. So that's really all the information that I need, because I can see that based on this has to be opening to the left. So this opens to the left, and the vertex is at HK, so that will be at the -7, 6, so that's HK. And then they want the focus. The focus is at H plus PK, so H was -7, P is -2, and K is 6, so this will be at -9, 6. And then they want the directrix, and remember the directrix is an equation, so that is x is h minus p, so h is -7 and p is -2, so we have x is equal to -7 plus 2, or x is equal to -5. All right, so there you go. So that is the vertex and the focus and the directrix. Now let's just sketch the graph here. So we have that the vertex is at -7, 6. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. So -7, 6. And then if you want to go ahead and actually, I don't know, if you want to draw another point, you can. It's really up to you. Like if I do that, I'm telling you, like if you want to do that, it's up to you. But I would say that it's not gonna open up too widely, probably. So so this was -7, 6. So yeah, it's really, well, actually maybe it will open up wider than I thought. Where will this be? Whew. Yeah, let's see. So oh boy. Humbug, right? Well, I'm telling you. Okay. All right. So uh yeah, so all right. So 1, 2, 3. Yeah, I'm just going to draw. You don't have to be that accurate. I just didn't want you to think that I was just drawing random shapes all over the place. But yeah, it looks like this. All right. Here, I'll be right back. It got a little bit warm here in the basement, so I turned off the space heater for a second. All right. So, again, if you have any questions, please feel free to ask. But I think that besides just making sure that you know whether the parabola opens up, down, left, or right, then there's not much to do, right? You just need to plug in the numbers into the correct set of informations. All right, so here is another one. Find the vertex, focus, and directrix of the parabola and sketch its graph. So again, just be aware that you want to pay attention to making sure that you complete the square here. And I know that this has an x squared but not a y squared term, so it's going to be of the form of x minus h squared equals 4p and y minus k. And then whether or not it opens up or down will depend on whether p is positive or p is negative. All right, so what I'm going to do is actually move all of the terms that don't have an x over to the right side of the equation. So we have x squared plus 2x will be equal to 20y and then minus 41. And if you remember before, what we did was we added in a half of b squared and a half of the b squared to each side of the equation. So remember the time when I wrote down the wrong b here. So just make sure that you know what b here is. It's 2 here. So we have x squared plus 2x plus a half of 2 squared. That will be equal to 20y minus 41 plus a half of 2 squared. So now what happens after that? Let me try to get a new marker here. Oh, ow. Actually, that was me stubbing my toe on the bottom of the chair. All right, so half of 2 is 1, so 1 squared. So x squared plus 2x plus 1 squared equals 20y minus 41 plus 1 squared, which is 1. So we have x squared plus 2x plus 1 equals 20y minus 41 plus 1. So here, what do I have here? I have actually a x plus 1 times x plus 1, so that's x plus 1 squared. And here I have 20y minus 40. Now, remember that I want to write it in this form with what's inside of the parentheses here having a coefficient of 1y. All right, so what I really need to do then is factor out the 20. So this will be 20 times y minus 2. And then I can rewrite it in this form by, remember, doing 20 divided by 4 will tell me what p is. So x plus 1 squared is 4 times 5 times y minus 2. And if I compare to the format up here, then I need to make this x minus negative 1 squared equal 4 times 5 times y minus 2. And h will be negative 1, the p will be 5, and the k will be 2. So then since the p is positive, this will be a parabola that opens upward. So since the p is greater than 0 positive, that means that the parabola opens upward. All right, so that's not actually too bad here, but now I do need to sketch the graph and find the vertex and all of that. So the vertex is still at hk, so that will be negative 1, 2. And the focus is at hk plus p. So h was negative 1, k was 2, and p was 5. So negative 1, 7. And the directrix is going to be at the directrix is at y is equal to k minus p. So that will be 2 minus 5, so y is negative 3. So there's the directrix and the focus and the vertex. And so now all I need to do is draw a sketch of this. And again, it's enough to sort of just label the vertex and then figure out sort of whether it opens up or down or left or right. All right, so the vertex was at negative 1, 2, and it opens up. So if this is opening up here, then I have a, by the way, this is not going to open up at a very fast rate, a very fast rate at all. It's you know, it just looks like that. So this is the vertex here, and the vertex is going to be again negative 1, 2, and that is the end of this problem right here. All right, so again, if you have any questions, please feel free to ask. But now here is a problem here. Find an equation for the conic whose graph is shown. So this is a parabola that is opening to the right. So since this opens to the right, I know it has to be y minus k squared is 4p x minus h, and p has to be greater than 0. So since, see, because if it's opening to the right, p has to be greater than 0, and I know that the directrix is y is equal to negative 12, and so what I do know, though, if you remember about how this all actually works here, is that this distance right here actually is p. So p is actually equal to 6. All right, so don't be alarmed here, but p is actually equal to 6. Hopefully that all made some sense of what is going on here, but p is equal to 6. So then this is the vertex right here. So the vertex is at negative 6, 0. So that's h and k. And I know what p is. So here we go. So y minus k, which is 0 squared, plus 4 times p, which was 6, times x minus h, which was negative 6. So we have y squared is equal to 4 times 6, 24, times x plus 6, and then I would actually leave it like that, but if you wanted to, you could go ahead and distribute this if you want it and make it 24x plus and figure out whatever that is, but 24 times 6 is just 144, so that's another way you could write this as well. So hopefully you did not find that to be too difficult there. All right, so now let's move on to the shifted hyperbolas. So let me go ahead and pull up the information that I wanted to tell you about the shifted hyperbolas here. Like sometimes I wonder about my my computer. All right, so if you have a horizontal hyperbola, and by that I mean one that is actually opening to the left and to the right, then the vertices are going to be h plus or minus a k, and the foci are going to be, all right, h plus or minus c k, and then the asymptotes are actually going to be, I actually don't know why my computer is doing that though, but asymptotes are going to be y minus k is equal to, oh no, all right, is equal to plus or minus b over a times x minus h. I wish that my computer would not do this. I'm telling you. All right. So if you have one, so this is what they call a horizontal orientation. So horizontal transverse axis. If you remember that word, transverse axis from the other day. All right. So then for hyperbolas with a vertical, actually, I don't actually think that's, is that the word that I use for that is transverse axis? Because I actually am going to double check and make sure that I'm using the same word that I told you the other day. Because, like I said, sometimes I tell you these other things, and I think that it's a yeah, the same thing, and then because I'm telling you this terminology, I would graph it correctly and then just realize, hey, I didn't say it the same as I said it the other day. Yeah, so vertical especially since I wasn't sure if I spelt transverse right. Vertical transverse axis. So the vertices for these types of hyperbolas are at h and then k plus or minus a. The foci are at h and k plus or minus c, and then the asymptotes are at y minus k equal plus or minus. And remember, you're going to reverse the a and the b here, so a over b x minus h. So very similar to before, but now you're just shifting by h and k. All right, so let's find the center, foci, and vertices of the hyperbola and sketch its graph using asymptotes as an aid. So we see that the x term comes first, so that means that this is a hyperbola with a horizontal transverse axis. So horizontal transverse axis, right? And then what does this mean here? Well, it means that the h is -3, the a squared is 4, the a is the square root of 4, 2, and then the k is 5, the b squared is 9, and b is the square root of 9, which is 3. So the center is at HK, so that will be -3, 5. The foci are at H plus or minus C and K. So we need to figure out what C is still, but C squared will then be, remember, is A squared plus B squared. So C squared then is A squared is 4, B squared is 9. So C squared is 13, so C is the square root of 13. So this will be H was -3 plus or minus the square root of 13, and K was 5. And then the vertices are at vertices. I think I spelled vertices right this time. I have no idea. All right, so vertices are at h plus or minus a k. So h is -3 and a is 2 and k is 5. So -3 plus 2, 5, and that will be, well, that will be a -1, 5, and -3 minus 2, 5. So that will be -5, 5. All right, so now let's draw a sketch of this hyperbola here. So here is a sketch of this. And if the vertices are at -1, 5, -1, 1, 2, 3, 4, 5, and -5, 5. So 1, 2, 1, 2, 3, 4, 5, -5, 5. Then if you know that this opens left and right, then really you just need to figure out the idea of this fundamental rectangle and go from there, or the central box and go from there. So if this was the center and I went 2 each direction from the center, 2, 2, that means I need to go 3 up and down from the center. So 1, 2, 3, and 1, 2, 3. All right, 1, 2, 3. And there is my central box, or my fundamental rectangle right here. And again, this means I don't even really need the equations of the asymptotes. I just need to go ahead and draw them in here. All right, so I'll just make sure that I draw them as accurately as possible so that when I draw the actual hyperbola, that I make sure that it opens in the as wide as it should. So in the correct width, all right? And then remember, this is a vertex, this is a vertex, and I have to make the hyperbola touch the vertex and then open out or pan out toward the 2 asymptotes. There you go, beautiful, right? So now let's try another one here. Again, if you have any questions, please feel free to ask. So find the center, foci, and vertices of the hyperbola and sketch its graph using asymptotes as an aid. All right, so let's go ahead and do that today. All right, so here we go. So this one we will need to complete the square. So we have 25x squared, and then we have minus 9y squared minus 54y equals 306. And to make it easier to complete the square, I'm going to factor out the negative 9. So negative 9 times y squared, and that will be plus 6y, and that will equal 306. All right, now remember that I need to add a half of b squared here, and then because this was actually a negative 9 here, I'm actually going to put negative 9 times a half of b squared, just like we did before when we had the 4 here that we had factored out. Now remember last time I had the wrong b, so just make sure again that you are paying attention to what the b is, and it's 6. So we have 25x squared minus 9 times y squared plus 6y plus a half of 6 squared equals 306 minus 9 times a half of 6 squared, and a half of 6 squared is 3 squared. So we have 25x squared minus 9 times y squared plus 6y plus 3 squared equals 306 minus 9 times 3 squared. So 3 squared is 9. So I'll go ahead and I will figure out what all of this is here, and then I can factor y squared plus 6y plus 9 into, what will this be? This will be y plus 3, y plus 3, and then this will be 306 minus 81, so 306 minus 81, that will be 225. So we have 25x squared minus 9 times y plus 3 squared equals 225. And remember that you want this equal to 1 and not 225. So I will divide by 225, divide by 225, divide by 225, and then that will be equal to 1. And 25 over 225 is actually 1 over 9, so this is x squared over 9, and then minus the 9, so 9 goes into 225, all right, so that will be, what is that? That should be 25 times, right? Yeah, so this will be minus y squared over, yeah, so here, let me rewrite this. Okay, so y plus 3 squared actually over 25, and that's all equal to 1. So here I know then that the form is of x minus h squared over a squared, and then minus y minus k squared over b squared is equal to 1. So I can figure out all of the information that I am being asked here, right? So I know that the h is 0, a squared is 9, so a is 3, the k is negative 3, b squared is 25, so b is 5. So if I want the center, that's at hk, so that's 0, negative 3. The foci, I still need to figure out what the c is. So c squared is a squared plus b squared, but a squared is 9 and b squared is 25. So what will that be? So 25 plus 9 is 34. So the square root of 34. So c squared is 34. C is the square root of 34. All right, I hope that you're enjoying this. I truly do hope that. All right, so the foci are going to be here. So that will be h and plus or minus ck. So h was 0. So 0 plus or minus the square root of 34 and negative 3. So plus or minus square root of 34 negative 3. So that's the set of foci. And then we need the vertices. And the vertices are at h plus or minus ak. So h was 0 and a is 3 and k was negative 3. So plus or minus 3, negative 3. So one of them is at 3, negative 3, and the other one is at negative 3 and negative 3. All right, and now let's go ahead and graph this. I guess I didn't leave very much room for that. What a time to be alive, right? So let's go ahead and I'll just get another piece of paper to go ahead and show you what the graph of this looks like. And it says use the asymptotes as an aid. So if you wanted to find the asymptotes in the equations of them, you could, but you don't have to find the equations of them. It just says to use them as an aid. All right, so I know that the sketch here we go. So the sketch is going to be, here it is. So the center is at 0, negative 3, and the A was actually 3, so I have to go left and right 3 from the center. So 1, 2, 3, and 1, 2, 3, and then up and down B, which is 5 from the center. So 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. All right, and then I'll draw in my central box or fundamental rectangle right here, and then go ahead and then sketch it from here. So let me get my ruler here again. So here is my ruler, and I need to make sure that this goes, the asymptotes go through the diagonals, the rectangle, and through the make sure through the center of the hyperbola here. All right, so try to be as accurate as you can, given that this is just a sketch, though it's okay if you're a little bit off. But the one thing that you need to remember is that this was a vertex and that's a vertex, right? That's a vertex and that's a vertex. So the graph has to touch the vertex. So start at the vertex and pan out each direction toward the asymptotes like this. All right, so there you go. So there is the hyperbola. So now let's go on to this next one here. And it says find an equation for the conic whose graph is shown here. So right now, all they tell us are the two vertices. So they tell us the vertex, and so one of the vertex, so this vertex is actually at, where is it? It is at 2 and 0, and this is a vertex that is at 6, 0, and the center is right here in the middle, so that will be at 4, 0, and this is opening left and right, so that means it has a horizontal transverse axis, right? So again, if you have any questions, just let me know. And so I know what the form is. The form is x minus h squared over a squared minus, because it's a hyperbola, y minus k squared over b squared is equal to 1. And so I know what h and the k is, hk, all right, 4, 0. And I know what the A is because it is right this distance right here. So it is 2. All right, so A is 2. So A is equal to 2. So I just need to figure out what the B is. So they don't tell me what the B is, but I do see some other points on the graph here, and one of them happens to be 0, 4, and one of them happens to be 0, -4. And so what I can do is use this as an x and a y to substitute in here to figure out what b is. So if I substitute in all of the information I am given here, and you know what, I was going to switch to another color marker because this is all blending in, but now the marker cap sort of went away, and I'm afraid to just leave it on the floor like this. Okay, so let me move everything out of the way here. I'll figure out where the marker cap went later. I just don't want to step on it and break my foot or anything like that, because that would be tragic today. All right, so now let's go ahead and substitute all of this information in here. So the x I'm going to use is 0, and the y is 4, and the h is 4, and the k is 0, and the a is 2. So x is 0, so 0, h was 4, so 4 squared, a is 2, so 2 squared, minus y was 4, so 4, and k is 0, so 0 squared, over b squared is equal to 1. So -4 squared is 16. So 16 over 2 squared, which is 4, minus 4 minus 0 squared. So that's 16 over b squared is equal to 1. 16 over 4 is 4. So 4 minus 16 over b squared is equal to 1. Subtract the 4, right? So -16 over b squared is equal to -3. So -16, if I multiply by b squared, is equal to -3b squared. Then divide by -3. So 16 over 3 is equal to b squared. And then I take the square root, and then b is equal to the square root of 16 over 3. But remember, I just really needed b squared to substitute into the equation. I don't even need to find b, really. I just need to find b squared. All right, so if a is 2, then a squared is 4, and then I can just write down what the equation is. So here is the equation today. All right, so the equation is going to be x minus h squared, so minus 4 squared, all over a squared, which is 4, minus the y minus the k squared, so k was 0, so y minus 0 squared, over b squared, so 16 over 3 equals 1. So we're left with x minus 4 squared over 4, and then I'll multiply by the reciprocal of the 16 over 3, so that will be, right, minus, right, 3 times y squared over 16 equals 1. And then I'll multiply by 16 to clear the fraction out. So 16 over 4 is 4. So 4 times x minus 4 squared minus 3y squared equals 16. And that is the final answer. Again, you could leave it like this, but it doesn't always look nice to have that double fraction right there. So that is the end of the shifting of the hyperbolas. So now I am just going to go over a little bit of how you would tell how to shift these left and right, if, or what type of conic they are, if they are not written in a form that's easily recognizable to you. Okay, so let's look at the first one here. And in the very first one here, I see that this has a minus right here. So I know that this needs to actually be of the form y minus k squared over a squared minus x minus h squared. All right, so just try to remember that this is the form here. All right, uh, over b squared is equal to 1. So this is definitely a hyperbola. All right, so this is a hyperbola. All right, the next one. This has a minus here, And so we know it's a hyperbola of this form, x minus h squared over a squared minus y minus k squared over b squared is equal to 1, so it is a hyperbola. Right? The next one, this has a plus here, so we know that it's of the form x minus h squared over the b squared plus y minus k squared over a squared equals 1, so it is an ellipse. This one, actually, the next one is actually a circle, but here is the thing, right? If you actually divide it by 4 and actually just made this equal to 1 over here, you would say it's an ellipse, right? But if the a and the b are equal, then remember it just becomes a circle instead of an ellipse. All right, and then for this next one, we would normally have to complete the square, but if you remember what I was telling you earlier here, right, you can look at the information here and make sure that it's in the correct ax squared plus cy squared plus the dx plus ey plus f equals 0 form, all right? So this is of the form, where is it? That will be, all right, so negative 4x squared, and then we want plus y squared, and then plus 8x, and then we have no y, so 0y minus 3 is equal to 0. So this is ax squared plus cy squared plus dx plus ey plus f equals 0. All right, so a is negative 4, and c is equal to 1 in this case. And so since these are, again, if these have opposite signs, then this is a hyperbola. All right, so these are opposite signs. One is negative, one positive. So opposite signs, that again means one negative and one positive. So that means that this is a hyperbola. So this one is a hyperbola. So if you don't need to find any information out about this except for what it really is like what type of conic it is, then you can use this method here. All right, so let's try another one here. So we have y squared minus 4y equals x plus 5. So, well, all right, I can go ahead and look at this. And by the way, I can tell you right away that this is a, a parabola because it doesn't have an x squared and a y squared. But if I set it in the form of ax squared plus cy squared plus dx plus ey plus f equals 0, then I have y squared minus x, all right, minus 4y minus 5 equals 0. So a is 0, c is 1, d is negative 1, e is negative 4, and f is negative 5. And since it said if a or c is 0, then this is a parabola. So a equals 0, so this is a parabola, right? So that's all you really needed to know about that particular one. So let's look at the next one. This one is in my opinion, a big mess here, but you can distribute the 4 here. So x squared plus 16 equal 4y squared plus 8x. So write it in the correct form with ax squared, then the cy squared, then the dx, and then the ey, and then the f. So x squared minus the 4y squared, so subtract 4y squared, then subtract the 8x, and there are 0 y's, and then you have the f, which is plus 16 equals 0. So a is 1, C is -4, D is -8, E is 0, and F is 16. All right, so then all you need to know then is that A and C are opposite signs. So A and C have opposite signs. So this actually is a hyperbola again. I hope that you're enjoying this, because this honestly, if you set it up correctly, I don't think that these are the most difficult ones here. So the next one is already in the correct form: a x squared plus b y, or c, sorry, c y squared plus d x plus e y plus f is equal to 0, right? So a is equal to 3, c is equal to 4, D is equal to -6, E is equal to -24, and F is equal to 39. So then I just need to look and see that these have the same sign. So A and C have the same sign. So that means that this is an ellipse. All right, now the last one is a little bit trickier. So I have, all right, so we have 16x squared. So, but then there's a term with the xy here. So this is in the form ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0. So a is 16, b is -24, c is equal to 9, d is equal to -7, e is equal to -5, and f is equal to 8. So if you have a xy term in there, then you need to do a slightly different procedure than if you don't have the xy term, like in this box here. All right, and you could actually just use this procedure all the time and just say b was 0 up here, but in either case, this is one thing that you could do. All right, so let's see. So we have to look at b squared minus 4ac, and that should be familiar to you because that's the discriminant of the quadratic formula, right? And so b squared minus 4ac in this case is -24 squared minus 4 times 16 times 9. So 24 squared. So 24 squared minus 4 times 16 times 9, that will be equal to 0. So since this is equal to well, all right, so what is this? Wait a second. Yeah, okay. So now, yeah, so let's go ahead and then I actually want to show you something real quickly, because I feel like even though that is equal to 0, it might not be obvious what that is right away. All right, so I am going to graph that for you. So minus 7x minus 5y plus 8 equals 0. And so if my computer, oh boy, yeah, it's a, yeah, anyway, this is, yeah, so this is equal to 0, so it's a parabola. Okay, so this is a parabola, but it might not be obvious that that's a parabola, since it had an x squared and a y squared in it. But that's just because it's a parabola that actually is at, it hasn't been necessarily, well, it's been shifted, but it's also been rotated. So just try to remember that as well. So the vertex is actually at, uh well, I don't actually, well, okay, if you want to solve it for y, it would be y is equal to 24. And this is what I mean, it's a mess. But okay, so 24 over 18x, and then plus or minus the square root of 492 x minus 263 over 18 plus 15 over 18. All right, so it is of the form where there's not an x squared in it, and the vertex of this happens to be at 263 over 492 comma 731 over 738. So if you want to graph this, then it actually looks something like to the effect of well, that's about a half of one, so something like this, opening at an angle like this. But those are not actually hyperbolas that you would graph by hand unless you are going on to a lot higher mathematics than what we have in here. But then sometimes in trigonometry, the next class after this one, they might do that, because you can figure out using sines and cosines and things like that that you might hear about in trigonometry. So this one again is a parabola. So unfortunately, that is it for this section on shifted conics. So I'm going to stop the video here.